I hope everyone has a good lunch. And we have a speaker from Malaysia, Miss Pratibha Jana. Sorry, I hope I pronounced your name properly. And she's very enthusiastic about Python Stasia, and then passionate for coding and books. And she's going to tell us about metaclasses and also the realm of metaprogramming. Okay, so Patricia, please. Oh, all right. Let me see. Actually, I have to do something.
Hello everyone, welcome to my talk on metaclasses. In this talk, we will explore the concepts of metaprogramming using metaclasses in Python. It is one of the most complex yet interesting topic in Python. It makes Python an extremely powerful programming language. We are going to discuss some examples about metaclasses and also why and when we should use them. Before I begin, I want to clarify that this is a complicated programming topic, and unless the requirement can only be solved by metaprogramming, I would recommend the developer choose a different programming approach. Therefore, only use metaclasses if you are absolutely have to use it. At first, the word metaprogramming seems like a very funky and alien thing. But if you have ever worked with decorators, you were doing metaprogramming there all along. In a nutshell, we can say that metaprogramming is the code that manipulates code. We often use decorators to enhance Python code and add extra functionalities to the existing functions and classes. These decorators are part of metaprogramming in Python. Code generators are also part of metaprogramming. We can introspect the functions, classes, type of an object and modify them at runtime. Some development environment like IDEs use the metaprogramming feature to provide code analysis. Also, expert level Python developers who intend to implement frameworks and their own libraries, especially in Python, often use metaprogramming feature of Python. Before I begin, let's remember that everything is an object in Python. Let it be a function, a constant, a variable. Literally everything is an object. To elaborate, even a class is an object. As a result, we can treat a class as any other object and pass the class as a parameter. We can store it and modify it at the runtime. We can say a class is an object that can be used to instantiate new objects. A class seen as a bucket that groups the objects. It defines the protocols and rules for the objects that it creates. But the question is, how to instantiate the class itself? I mean, if a class is also an object, just like any other object, it must be an instance of something, right? Let's explore that. Now we are introduced to term metaclass. A metaclass is what instantiates a class. It groups a set of classes together. We can have meta information about classes within a metaclass. This whole meta thing can be summarized as metaclasses are responsible for creating classes, and classes create the objects. For example, in Python, a special class type creates these class objects. The type class is default metaclass. It is the type class is the default metaclass, which is responsible for making other classes. That is why in Python everything has some type associated with it, because every type in Python is defined by a class. Unlike C++ or Java, where integer, character, floats are primary data type, in Python they are objects of integer or string class. As the class can add protocol or rules to an object, a metaclass can add protocol or rules to a class. And Python uses a metaclass to create a class for you. So the first key note to remember is that everything is an object in Python, including a class. And each class is created by a metaclass. For example, let's consider this code. This method returns the class PyCon example. So we have a function that basically have class definition inside, and it returns that class. Before we move any further, let's see what does we get if we try to print it. So if we try to print the return that we get from this function, it will be basically the class itself. Now let's understand what the type is. The type function or the constructor of type class is called to retrieve the type of an object. For example, I can print this particular line because get PyCon example belongs to the class function. But the next print command, which is this, gives different result. That is because the return of get PyCon example belongs to the class type. The second key note to remember is that each class is an instance of the type. Here TYPE is the capital type I would suggest to remember, because it's basically the meta class where in Python everything is derived from type. This class is used to create other classes in Python. It defines rules and protocols of the classes it creates. Let's consider our next example. It's again a class. The class PyCon example has a constructor that takes in a block name and a method that returns the name of the block. Now we learn that the constructor of the type can be used to create classes. that can then create instance of the class. Let's first see what are the parameters allowed in type. The constructor of the type takes in the following parameters: CLS, what, basis, and dict. CLS is the name of the class. What is the tuple of base classes. The third parameter is a dictionary of key, which are attributes and their implementations. As we can see that the dict parameter is where we pass in a dictionary with two keys, where the keys are the method name and the value name. And the values are the implementation of the methods. So how we can do that? Like this. As I said, keys can be the method name and values are the implementation of the methods. Now we are going to create meta example class by using the type constructor without declaring the class itself. As you can see, we are using the type constructor here, and we are directly passing all the names and the variables, for example the init function and what it is supposed to do, the get block name function and what it is supposed to do, and of course the class name. This is equivalent to creating the Metaclass example class that we did ourselves. In both cases, the creation of AND object or the final object and output of the get method is same. In both cases, we can directly use the class name and use the init function as a standard regular approach that we always do. This is also the reason why we have a dict property for all of our projects, for all of our objects. Now, how do we do metaprogramming? We can start by creating our own meta class. First step is to create a class that inherits from the type. The type will add additional behavior to the new meta class. Now we have to remember one more thing here. A class can only have one meta class. Let's have a look at this code snippet step by step. The snippet of code above shows that we have created a new meta class called PyCon meta. The key point to note is that Metaclass is defined by inheriting from type. When we create a class, we can set the Metaclass attribute we can set the Metaclass attribute to a class that is inherited from the type. Now the Metaclass will have a new method that calls type new. We can now add validation rule in the meta new method and validate all of the parameters. The new function here is another example of metaprogramming. It creates new class instances and it is not bound to an instance of the class in nature. This method is called before init is called. We can override the superclass new method by this. The return of new method is the instance of the class itself. Hence, it is useful when we want to modify the creation of immutable data types such as tuples. Now I'm going to modify this new method because I'm not happy with it. What I'm going to do is I'm going to add some validation into it. I'm going to modify the new method of PyCon Metaclass and checks that the class has a method getBlock. Now I will create a new class called PyCon example. Now this PyCon example class have PyCon Meta as its meta class. Notice how setting the meta class attribute at class level is required. As a result, when I run this code, even before instantiating the PyCon example object, it will break as soon as the module is loaded. Can you see in the exception it says that getBlock is missing? Because even before I created an instance of the class, when it tried to load the parent meta class, it sees that there is no getBlock function and hence it is breaking. This is how we can enforce every class to have certain methods or certain attributes that our framework or our library requires. Now let's do some more thing in it. I can now create a new class PyCon example and have its meta class as PyCon Meta, and ensures that PyCon example contains the getBlock method. Now as soon as I create the PyCon example class and loads the module, it will print out this. We can see the printed dictionary. This particular dictionary is getting printed because of print dict statement in PyCon meta class. We can use meta class new method. It is called whenever a class is instantiated, and it is called before the initialization or init method. So we can use it to enforce whatever restrictions we want to have on all the subclasses or the child classes throughout the hierarchy. Now, metaclasses can be used to modify the class attributes itself. As an example, I'm now going to modify all of the methods so that they are now prefixed with my name, Pratibha, because I like all methods have my name. The functionality of Pratibha getBlock will remain as the functionality of getBlock above. I'll give you a second to read it through. Now this is how we can add new method to class via metaclass. Even though Pratibha getBlock doesn't explicitly exist in the PyCon example class, but the meta class added it for us because before init method, new method had run and it has instantiated it with a Pratibha getBlock function. As a result, when we print the output of Pratibha getBlock, same output is printed as if we have run just the getBlock. Now, we have seen that we can use metaclasses to control or restrict or validate, we have seen multiple use cases currently using the basic examples. We can successfully say that, or we can with confidence say that the main use cases that we have seen so far, we can use meta classes for validation of new classes or adding dynamic code to new classes. Most of the time, we do not be using meta classes. It is usually used for something complicated. But there are few cases where we definitely use meta classes, and that's what make it stand apart. Let's see what are the points where meta classes are the best option or the most optimal solution we have. Now, meta classes propagate down the inheritance hierarchy. It will affect all the subclasses as well. For example, if we want to apply method decorator all the classes which inherit the class, we are going to use meta classes. Then if we want to check that a class was defined correctly, we can use meta class. Of course, to raise the error during the import modules, we can add meta hooks that are called before any other import is called. This can be done by adding sys.metapath and are called as part of sys.path processing basically. Also, if we want every module of our framework to have methods with a particular signature, or if we want to have our classes to have certain naming conventions and attributes and methods, then we can use metaprogramming to achieve it. As I said in the starting, code generators heavily use metaprogramming. IDEs use metaprogramming to provide code analysis because you can introspect functions, class types, and modify them at the runtime. Of course, each time a base class is subclassed, we can run specific code, and that can be achieved best by metaclass. We can use a subclass to annotate or modify properties before even the class is being used. And of course, metaclass can validate all the classes, and it can also be used to set attributes for your class beforehand. We often use special methods and metaclasses to change the way Python objects work. We can even extend Python syntax by creating our own domain-specific language, that is DSL, using abstract syntax tree, that is AST. Object relational mapping ORM classes traditionally use metaclasses. Developers who concentrate on writing frameworks often use metaclasses. As Tim Peters suggests, metaclasses can easily veer into the realm of being a solution in search of a problem. It isn't typically necessary to create custom metaclasses. If the problem at hand can be solved in a simpler way, it probably should be solved in a simpler way. Still, it is beneficial to understand metaclasses so that you understand Python classes in general and can recognize when a metaclass really is the appropriate tool to use. I hope this talk has been helpful to you, and if you have any questions, please feel free to reach out to me. Have a great day ahead.
Okay, so here's the link for the talk. And I would like to know if anyone want to ask any questions. If no one asks a question, may I ask one? So, Pratibha, how often do you yourself use metaprogramming or metaclasses?
Hi, can you please repeat the question?
I repeat the question, is it?
Yes, please.
Yes. Okay, just a moment. Okay. Um, how often do you use metaclasses or metaprogramming?
So I have used Metaclasses just one in my 10-year of career when we had to create a custom library for a proprietary work. There we used Metaclasses because we wanted all the subclasses which are inheriting it should have a proper structure, it should have a restricted number of function calls and should not be able to extend it. That's where we used it. Apart from that, because 99% of things which we need are already available using decorators or other approaches which are easily understandable and configurable. But with meta classes, when we used it at that time also, we had to be very careful because we understood that if something goes wrong, all the objects that are getting created will behave abnormally. That's the only point when I used meta classes.
Okay. Yep. So, any people want to ask more questions? Okay. No. We think we might just stay around until 2:30 and see if anyone would like to ask a question. Okay, so first, um, thank you, Pratibha, and and I will I personally will remember all this and see if I have a chance to use meta classes.
Thank you so much, everyone, for attending this call. It's a nice experience. This whole conference is very good experience for me. Thank you, everyone.
Thank you.